Today from us Apex students. For this video, we're gonna tackle Earth and Life Science. Me, a not-so-intelligent student, is conducting a series of research about rocks, minerals, and continental drift. Together with my other groupmates, they will be answering some questions I'm interested in about Earth and Life Science and helping me to learn more about it. So, let's start with Earth, the only planet to maintain life, a product of scientific phenomena and sheer chance. This blue speck in space holds the past, present, and future of our every existence. A world of vast ocean and stormy seas. A world of magnificent clouds and life-giving rain. It is a world of towering mountains and vivid ice. It is a world of forested hills and desert sand. Most of all, it is a world of spectacular beauty.
A beautiful place indeed. Now, minerals are those elements on the earth and can also be food that our bodies need to develop and function normally. Miss Kimberly, can you share some info or your knowledge about minerals elements?
Certainly, a mineral is naturally occurring substance. It's represented by a chemical formula that is usually solid and organic and has a crystal structure. Minerals possess different chemical compositions which define their crystalline shape and form. Minerals grow or cement together to form rocks.
Now, those minerals have some physical properties, don't they? Some minerals are easily identifiable, others can only be recognized by the use of petrographic microscope or by the complex analytical techniques. Most minerals can be characterized and classified by their unique physical properties: hardness, luster, color, specific gravity, cleavage, fracture, and tendency. Now, minerals are the building blocks of rocks. Rocks composed of one or more minerals sometimes have mineraloids but do not have a crystal structure. Now, Ashley, can you elaborate further?
Certainly, rocks are composed of one or more minerals and sometimes mineraloids but do not have a crystal structure. Rocks do not have a definite chemical composition, whereas minerals do. Sometimes, rock may contain organic remains in it. Rocks also exhibit some physical properties like color, shape, luster, texture, and pattern. Older rocks that are the same age and are located on the same continent point to the same location, but that location is not the current north magnetic pole. Older rocks that are of different ages do not point to the same location or to the current magnetic north pole.
We have three types of rock classified in a way in which rocks form. Rocks can be identified by color, shape, texture, luster, and pattern.
Yes, those three types of rocks, igneous rocks, they are from the cooling of magma or lava. Igneous rocks can be classified in various ways. First, instructive or platonic. It takes long time to cool and have a size over 10 mm and it has coarse texture. The longer the cooling time, the larger the crystal size is. While extrusive or volcanic are erupted lava on Earth's surface and cooled quickly, which cause the crystal within it not to be able to grow larger. Extrusive size is mostly less than 1 mm and non-crystalline. It also has the glassy and fine texture. Second is sedimentary rocks. They are formed by the consolidation of sediments that settle out of water, ice, or air and are accumulated on Earth's surface, on dry land, or underwater. And lastly, metamorphic rocks. Exposed to intense heat or pressure will change or morph into something new. Foliated metamorphic rocks can often look like twisted layers in rocks, while non-foliated metamorphic rocks do not have a layered or banded appearance.
But how do rocks behave under different types of stress?
Stress causes the buildup of strain, which causes the deformation of rocks and the Earth's crust. Compressional stress causes a rock to shorten. Tensional stresses cause a rock to elongate or pull apart. Shear stresses cause rocks to slip past each other.
Now let's find out how rocks undergo weathering. Weathering of rocks refers to the process of weakening and breaking down of minerals and rocks, both non-living and living elements, such as temperature variations. Plants and animals, acids, salts, and water can contribute to this. The weathering of rocks happens gradually over time. Rocks underground often weather more slowly than those on the surface of the earth. Weathering is one of the processes that result in the creation of soil. Rocks are affected by several weathering processes. This includes chemical weathering, biological weathering, and physical mechanical weathering. Rocks are actually disintegrated by physical or mechanical weathering. The freezing and thawing of water is one form of physical weathering because when water freezes, it expands. The ice then works as a wedge. It slowly widens the cracks and splits the rocks. When ice melts, liquid water performs the act of erosion by carrying away the tiny rock fragments lost in the split. Water can pass through any pores or fissures in rocks. Rocks will eventually shatter and flake if this extreme temperature variation occurs repeatedly over an extended period of time. Exfoliation is the term for this process. Extremes of temperature can also influence how rocks weather. The term thermal stress refers to one of physical weathering. This is a typical element in desert regions where the daytime heights can be very hot and the nightly lows can be fairly chilly. Another form of physical weathering is abrasion, in which rocks are gradually exposed and decomposed by repeated friction from wind, water, or ice.
What are the other forms of weathering?
I can answer that. Another form of physical weathering is abrasion, in which rocks are gradually exposed and decomposed by repeated friction from wind, water, or ice. In an instance of chemical weathering known as oxidation, iron-containing rocks will react with oxygen and water to produce rust. When it comes to iron, rust has the traditional reddish-orange hue. Rocks will be eroded by this rust. The actual chemical bonds of rock will change during hydration as a result of water absorption. This is how water converts anhydrite to gypsum. Rock deformation is a result of hydration. When a rock is dehydrated, water is removed from it, as when hematite is formed when limonite had its water removed. Now, back to you, Sir Cyril.
Thank you, Miss Juliana. Minerals undergo hydrolysis when they are exposed to acidic water, creating solutions to saltwater solutions. The widely used clay, minerals, and quartz are also produced by chemical weathering, which hydrolyzes feldspar. Kaolinite and other materials can be produced by hydrolysis of orthoclase, an alkaline feldspar. Rocks weather more quickly as a result of all of these chemical reactions. Due to heat and an abundance of water from rain, chemical weathering happens more frequently and more quickly in tropical areas. A form of weathering called biological weathering is brought on by microbial, animal, and even plant forces. For instance, as tree seeds mature into adult trees, they gradually break apart rocks. Tree roots will continue to expand and cause rock fissures. Rocks can also be broken down by animals that dig, like moles. Even above ground animals can erode rocks as they move across the terrain. Carbonic acid, a byproduct of both live and dead plants and fungus, has an impact on rocks. In lichen, fungi eat down rocks to liberate minerals, which symbiotic algae then consume. This process leads to holes in the rocks. The mineral makeup of rocks can weather and change even by small microorganisms. All of the biological activity throughout time causes rocks to weather more quickly. I recommend that we should start collecting rocks now because rocks are wonderful. They tell us a story about the past.
Just like the continental drift theory that Alfred Wegener proposed, he hypothesized that the continents were moving or drifting away slowly. He came up with the continental drift theory, which states that at one time, the Earth had one giant supercontinent called Pangaea. Wegener came up with this idea because he noticed that the coast of Western Africa and Eastern South America looked like puzzle pieces, which might have once fit together and then drifted apart. Looking at all of the continents, he theorized that they had once been joined together as a supercontinent, later around called Pangaea, around 225 million years ago.
Pangaea is not the only supercontinent believed to have existed. Older supercontinents are also believed to have come before Pangaea. In early geologic time, a supercontinent that incorporated almost all the land masses on Earth. Pangaea was surrounded by a global ocean called Pantalassa, and it was also fully assembled by the early Permian epoch.
What are the lines of evidence of continental drift theory?
The four pieces of evidence for the continental drift includes continents fitting together like a puzzle, scattering ancient fossils, rocks, mountain ranges, and the old climatic zones locations.
What are the causes of continental drift?
Various Earth scientists have proposed the cause for continental drifting. One of the main causes is explained by plate tectonics, which proposed that the plates move by the convective flow of mantle material. Some related mechanisms are ridge push and slab pull. Now, the plate motions cause mountains to rise where plates push together or converge, and continents to fracture and oceans to form where plates pull apart or diverge. The continents are embedded in the plates and drift passively with them, which over millions of years results in significant change in Earth's geography. Faulting is a process that occurs due to the intense strain on plates that is endured by the faulting plates. The pressure of compression or tension results in a fracture to occur in fold in which can form along a fault line.
I heard that sea floor occur at divergent plate boundaries.
Yes, as tectonic plates slowly move away from each other, heat from the mantle's convection currents makes the crust more plastic and less dense. The less dense material rises, often forming a mountain or elevated area of the seafloor. Eventually, the crust cracks.
How about the structure and evolution of ocean basins?
Ocean basins form initially by the stretching and splitting of continental crust by the rise of mantle material and magma into the crust to form a new oceanic lithosphere. Among the major ocean basins, the Atlantic has the simplest pattern of ocean floor eddies.
What about what will happen after the magma is formed?
Well, in the form of plutonism, the process by which magma rises through the crust and crystallizes on the intrusive igneous rocks beneath the Earth's surface. Pluton is generic word for any igneous intrusive rock body. Exactly what causes melting is complicated and variable, while in volcanism, the eruption of molten rocks onto the surface of a planet. A volcano is the vent through which magma and gases are discharged. Magma that reaches the surface is called lava. Volcanoes are named for Vulcan, the Roman god of fire. Most magma that arises through the partial melting of source or parent rock regardless of composition. The collected buoyant magma acid contributing to volcanism or more often when becoming stalled at depth, plutonism. This overall process is magmatism.
You see, the Earth's internal heat comes from the main sources of heat in the deep Earth. Number 1. Heat from the planet formed and accreted which has not yet been lost. Number 2 is frictional heating caused by denser core material sinking to the center of the planet. And last, number 3, heat from the decay of radioactive elements.
Magma is formed magmatism. Transfer of heat often happens at convergent boundaries where tectonic plates are crashing together. As a denser tectonic plate subducts or sinks below, or the less dense tectonic plate hot rock from below can intrude into cooler plate above. This process transfers heat and creates magma.
Scientists created a geologic timescale to visualize the order and time frame of significant events on Earth over the last 4 billion years. The earliest emergence of plants life on Earth, the first appearance of animals on Earth, the construction of Earth Mountain, and the extinction of the dinosaurs are all examples of events recorded on the geologic timescale.
The geologic time scale shows the geologic time interval based on the geologic rock records, which describe the relationship between the events throughout Earth's history. The sequence of events is based on the radiometric dating of igneous rocks associated with the fossils bearing sedimentary rocks. A geological timescale is one of the examples of how geologists combine dating methods. Relative dating puts rocks and fossils into a sequence. Absolute dating provides the actual dates. Index fossils are used to define geological period. These fossils can be defined as commonly found, widely distributed fossils that are limited in time span. If one finds an index fossils in a given layers, then one has bounds on the age of the layer using index fossils. The geological periods are defined. Now, I hope we gain knowledge about Earth and life science. I hope we can talk about Earth and life science again. Also, I would like to thank Miss Ariane for inviting me here today.
It has been an honor to be among such outstanding people and to be able to share my perspective with you all. Thanks for having me here and have a wonderful day.
It has been a great conversation we had. The Earth is genuinely astonishing. There were things we're not able to optically discern and do. Spiritually, we've encountered an abundance of rocks that it may be hard to classify, but we hope our group helped shed some light to it. Now, to end this video, we have discussed a lot of things that are part of Earth and Life Science. I would like to thank Miss Juliana and Miss Kimberly for joining me here today. And thank you to Miss Ashley, Sir Cyril, Miss Rochelle as well.